Hi everyone, I'm Ashini here. I'm a machine learning intern at IIT. Today we are going to present the performance of crossbar-based long short-term memory with the agent memristors. So these all are the content that I'm going to follow today. Hence, we all know the memristors becoming more and more popular nowadays. It has received a major attention in neuromorphic systems. Memristors can be used as memory or the computational unit. And when it comes to neuromorphic computing systems, memristor plays a major role as a crossbar arrays. Crossbar arrays are used for multiply add operation, which in terms we can simulate using memristor units. We can program to multiple conducting states. Hence, we can relate the synaptic junctions in neuromorphic systems as the memristor unit. Here, we are going to consider how aging can affect the memristor crossbar performance. The crossbar structure, which we are considering here, is the LSTM neural architecture. This is the methodology, the overall workflow. First, we are starting with the implementation of neural network. We are considering LSTM neural network. Then after implementing, we are taking out each layer and extracting the weights. After extracting, we are quantifying the weights for mapping the weight values into corresponding resistor or the conductance values in the memristor. After implementing or after getting the crossbar structure, we are applying the aging types and analyzing the performance of the LSTM crossbar architecture. For implementing the neural network, we are considering there are two dataset cases. First one is SMS PALM dataset, next one is IMDb movie review. Both are in text format as well as both contain binary classification problem. And after getting the neural network structure, we are taking the values into a crossbar array format, and then we are applying the aging into that crossbar arrays or after the weight mapping. After applying the aging, we are analyzing again the performance of the neural network structure. So as I told earlier, this is, we can say, as a neural network structure, and we are taking out each layer and we are the quantize the n cross m matrix of weight values into 2 to 64 levels. We have considered levels which are minimum of 2 and maximum of 64 levels. Next is the mapping process we are occurring. We have mapped the weight of the layer weights into adjacent conductance levels. Hence, till now, we have mapped the weight values into conductance, and we are getting a finite number of conductance levels. Then the process starts, how we can apply the aging into the conductance levels. There are three types of aging that we are considering. First one is failure type 1, failure type 2, and failure type 3. In failure type 1, both R1 and R0 values are decreased to a smaller resistance rather than the original R0. In failure type 2, it's just opposite to failure type 1. Both R1 and R0 values are increasing to a higher resistance value than the original R0. Then when it comes to a failure type 3, it's just a combination of failure type 1 and failure type 2, that R0 is decreasing and R1 is increasing, and both reaches an intermediate value. As you all can think, like when it is increasing or decreasing, the level of values or the level of conducting levels are getting decreased. Hence, we can see how this happens. To demonstrate this, you can see in these figures, in failure type 1, R0 and R01's values are getting decreased. And while aging happens, we can see the level of conducting levels are getting decreased. For failure type 2, the lower levels of conductings are getting decreased. And when it comes to failure type 3, as you can see, both upper, that is both upper layer values, as well as lower layer values are getting decreases simultaneously. So when we think about failure type 3, it's most getting dangerous situation than failure type 1 and failure type 2. Hence, the values which comes under those regions, those blue regions, will map into a single R0 or R0 value. This can affect the whole neural network computation, as each layer weights represent the computation results which is calculated in order to reduce the error. Hence, we can see what happens when it comes to a neural network performance with respect to the aging problem. This is the mapping of layer weights. As you can see, weights in between these two layers are mapped into either lower or the above conductance level. As the number of levels getting increased, you can see more weights are mapped correctly. This table shows the relative output current error from the crossbar structure. As you can see, when we are moving the number of levels into 2 to 64, the errors are also decreasing. And this is the neural network performance against different failure types for the dataset 1 and dataset 2. You can see the number of cycle, if the number of cycle is getting increased, and the accuracy is getting decreased and the corresponding precision recalls values are getting decreased. And also you can observe a pattern like when pattern that failure type 1 and 2 has less impact or less effect than compared to failure type 3. As we have already seen, the number of levels in failure type 3 is getting decreased more faster than failure type 1 and failure type 2. And this is just how the aging process happen. We are just mimic how R1 and R values can change with respect to a finite number of cycles. So in the first figure, both R and R values are getting decreased, and decrease it reaches to beyond a minimum of R value. And when it comes to figure 2, both R1 and R values are getting increased, and it is going above R value. In failure type 3, both R and R values are joining into a middle position. These all are the most worst case scenarios, and it can be any gradual degradation, or it can be with respect to number of cycles, it can change, it can vary the number of conducting levels. So this plot shows the relative change in accuracy. That is, you can see in the first figure is for the relative change in accuracy for dataset 1, and second one is for dataset 2. As you can see, the blue dot showing failure type 3. We can see we have all the plots to describe the change in related to the failure types. Hence, for dataset 1, the sudden change in the accuracy we can see for the failure type 3 rather than failure type 2 and failure type 1. But in case of a showing figure, you can see the failure type 2 is showing more sudden change in accuracy than failure type 1 and 2. So this is the decrease or the aging effect is also depending upon the neural network architecture and which failure type it is undergoing. And finally, we have studied all the effects of aging, of course, by performance of neural network architecture. Aging leads to the reduction of number of conductance level, which affect the crossbar performance. Aging is also depending upon the device level features and different which failure type it undergoes and the neural network architecture. And this is an open thought of a design optimization of memristor neural network that extended the mapping device level reliability challenges with the architectural optimization. These all are a few references. Thank you.